Hello students, in this video I'm going to show you how to balance a redox equation in acidic solution. And this works because you're always going to balance things in acid before you balance them in base. So it's a good work through and a good skill to have. So we're going to balance this equation. You may recognize it as your ANK question today in class. Hydroperoxide and permanganate ions become oxygen gas and manganese dioxide. The first thing you need to do is assign oxidation numbers. Now, hydrogen is always +1. Oxygen in this case is -1 because it's in a peroxide, hydroperoxide. If you add up, the two -1s plus that one for the hydrogen, you get the overall -1 charge of the hydroperoxide ion. In manganese, the oxygen is -2 because that's not one of the exceptions, and therefore the manganese has to balance out the total of 8 negative charges from those oxygens. If we want to get that -1 overall ion charge, manganese will need to be +7 because 7 minus 8 is -1. In the oxygen gas, the oxidation number is 0. 0 is always the oxidation number of pure elements. And finally, you have the manganese dioxide. Each of those oxygens is worth -2, so this has to be +4. Now we're going to identify our reducing agent and our oxidizing agent. Our manganese goes from +7 to +4. That is a change of -3. That's a reduction. Here's our reduction half reaction. Therefore, manganese, the permanganate, must be our oxidizing agent. The oxidizing agent is reduced because it's accepting electrons, forcing something else to be oxidized. Then we also need to see that our oxygen goes from -1 in the hydroperoxide to 0 in the oxygen gas, giving us a delta oxidation number of +1. This is our oxidation. And therefore, hydroperoxide is our reducing agent. That is because it is giving up electrons, it is being oxidized, which affects a reducing reaction elsewhere in this system. So now that we know this, we can write our oxidation and reduction half reactions. The oxidation half reaction is the hydroperoxide to oxygen gas, and the reduction half reaction is the permanganate to manganese dioxide. And now we're going to balance each one of those using our rules for balancing an acidic solution. Let's start with the permanganate reaction. MnO4- goes to MnO2. The manganese is already balanced. Next, we need to do the oxygens. On our reactant side, we have 4, and on our product side, we have 2. Therefore, we need to add 2 water molecules to the product side. Now we need to balance hydrogens. On the reactant side, we have no hydrogens. On the product side, we have 4. Therefore, we're going to add 4H plus to the reactant side. I'm sorry, we need 2 water molecules to balance that out. All right, so we've got 4H plus MnO4- goes to manganese dioxide and 2 waters. Our last step is to balance charge. On our reactant side, the total charge is 4 times +1 minus 1 for the permanganate to give us a total charge of +3. Whereas on the product side, all of these are neutral molecules, so the charge is 0. We have to neutralize that +3 by adding 3 electrons to the reactant side. Now we have a total charge of 0 on either side. This half reaction is balanced. Next, we're going to balance the oxidation half reaction. That's the HO2 minus becomes oxygen gas. Our oxygens are already balanced. Now we have to balance the hydrogens. We have one hydrogen on the reactant side, and we don't have any on the product side. So we're going to add one H plus to the product side to balance the hydrogen. Now we need to balance our charge. On the reactant side, the total charge is -1. On the product side, the total charge is +1. So therefore, we need to add 2 electrons to the products to counteract the positive charge and give everything an overall negative charge. So we've got the -1 charge here. We've got 1 plus 2 times -1, which is -1. So that all balances. These are our two balanced half reactions. The next step we're going to look at the electrons involved in each of the half reactions and multiply one or both of them by a whole number to balance electrons. In our oxidation half reaction, we've got 2 electrons involved. In the reduction, we have 3 electrons involved. Therefore, that the least common multiple between these two is 6. We're going to multiply the oxidation times 3 and the reduction times 2, so that we'll end up with 6 electrons on either side before we combine our reactions to our final reaction. So if we multiply our oxidation reaction by 3, we get 3 HO2 minus goes to 3O2 plus 3H plus 6 electrons. If we multiply our reduction by 2, we get 6 electrons plus 8H plus 2 MnO4 minus becomes 2 MnO2 plus 4 H2O. Now we're going to add those two half reactions together to make our full equation. And we're going to end up with 6 electrons plus 8H plus 2 MnO4 minus plus 3 OH2 minus goes to 3O2 plus 3H plus 6E minus plus 2 MnO2 plus 4H2O. We're going to then cancel any species that appear on both sides of the reaction. So that's going to be the electrons first. We made sure of that. Then note that we've got 8H plus and 3H plus. We're going to cancel those to give us 5 left in the reactant side. The manganese or permanganate ion gets to stay. So does the hydroperoxide ions and the oxygen and the manganese dioxide and the water. We're going to do our idiot check really quick. We're going to start by counting up the hydrogen on each side. We've got 5 plus 3, which is 8. Then on this side, we've got 8, which is 4 times 2. We're going to check our manganese. 1, 2, 1, 2. We're going to check our oxygens. We've got 2 times 4 plus 3 times 2, which is 8 plus 6, which is 14. We've got 3 times 2 plus 2 times 2 plus 4, which is 6 plus 4 plus 4, which is 14. Then lastly, we're going to do our charges. On this side, it's 5 times plus 1 plus 2 times -1 plus 3 times -1. which is a total of 0. No, which is a total of 5 minus 2. Oh, minus 1. There we go. Minus 3, which is 0. On this side, everything is neutral, so it's 0. Our idiot check is good. So then we're going to write our final balanced expression. For things like permanganate or oxygen gas, you can go to your original equation and pull those out. Otherwise, there are a couple of rules. Hydrogen ions, the H+, are always aqueous. In this case, the permanganate ions are aqueous, and so are the hydroperoxide ions. The oxygen molecules are gas. The manganese dioxide is a solid, and the water is always a liquid. This is our balanced equation. I'll see you guys on Wednesday.